Hi, the topic of this video lesson is rectangular coordinate system in space. You've probably heard about the rectangular coordinate system on a plane. We denote it as x, o, y. Since we have this one plane, we can consider this plane and draw a perpendicular to this plane at point O. Let's do it. Just draw this plane in a different way. Let's make it so that x was directed here now, and y-axis here. And we draw a perpendicular to this plane at point O. Just like on these two axes. We marked the direction on this straight line. We direct it upwards for convenience. Thus we've got another axis, which we will call the OZ axis. Now we have three mutually perpendicular, pairwise perpendicular lines in space. The direction is set on these straight lines. The beginning is set as well. Then it is said that a rectangular coordinate system is given in space. Axis OX, just like on a plane, called the abscissa. Axis OY is called the ordinate, and axis OZ is the applicate. The plane OXZ, the plane OXY, and the plane OYZ are called coordinate planes. In order to find the coordinates of a point in space, we do the same as with the plane. Let's mark some point here, M, and try to find its coordinates. Let me remind you that to find the coordinates of this point on the plane, we drop the perpendiculars to the axis from this point. The corresponding values that we've got on the axis were the coordinates of the given point. We do the same here. We drop perpendiculars from the point M to these axes. In this case, it is more convenient to do the following. To drop the perpendiculars not on the axis, but on the planes themselves. That is, from the point M, we drop the perpendiculars to the plane, OZX. Let's say it was dropped somewhere here. Then, drop the perpendicular to the plane OXY and to the plane OYZ. Let's say it's somewhere here. Now using the obtained points, the origin and the point M itself, we can complete the building to a rectangular parallelepiped. To do this, we drop the perpendiculars. These lines are no longer visible here. And now, the points where the corresponding planes intersect our axis, in this case, this is this point, and this point, and this point, will be exactly the basis of the perpendicular from the point M to the relevant axis. Let's denote this point as M1, this point as M2, this point as M3, thus the coordinates of the point M will be the following. The x-coordinate of the point M is equal to the length of the segment OM1. If point M1 gets to the other side from the origin, then it is obvious that there will be a minus sign. Similarly here, we have OM2, the length of the segment OM2, also with plus or minus, depends on where the point M2 is located, and OM3. The length of the segment OM3 also depends on where the point M3 is, above the point O or below. It will have plus or minus 2. The coordinates of the points are found in the same way as we found them on the plane. Let's take a look at the following example. Let's suppose we have given points with the corresponding coordinates. Let's try to draw them. As in the case of the plane, the coordinates are indicated in brackets, separated by a semicolon. Accordingly, we have 3 coordinates, so there will be 3 numbers. Let's draw a rectangular coordinate system in space. Denote this axis x, this y, this z. This is the origin, point O. And let's try to draw. Let's start at point A. It has x-coordinate 3, y-coordinate minus 1, and the z-coordinate 0. If the coordinate is 0, then this point will lie on the xy plane. It remains to draw a point on this plane with coordinates 3 and 1. We mark 3 on x, minus 1 on y, so we will go in this direction. Now we draw straight lines through these points that are parallel to the corresponding axis. Through this point, a straight line parallel to the OY axis. Through this point, a straight line parallel to the OX axis. And where they intersect, there will be point A, with coordinates 3, minus 1, and 0. Let me remind you once again that if the third coordinate is 0, then the point lies in the XOY plane. The x-coordinate is 0, so it lies in the plane that contains the other two letters. Point B has x-coordinate 0, y0, z minus 7. If x-coordinate is 0, then it will lie in the plane XOYZ. If y-coordinate is 0, then it lies in the plane OXZ. Thus it lies at the intersection of these two planes, that is, on the OZ axis. That is, if two coordinates of a point are 0, then it will lie on the third axis. In our case, it lies on the z-axis, at the point minus 7. That is, it is below point O by minus 7. 1, 2, 3, 4. It is somewhere around here. This is the point, B. Point C has coordinates 2, 0, 0. That is, x is 2, y and z is 0, so it lies on the OX axis. We mark 2 at x-axis. Have already marked. This is our point C. Now point D. It has y-coordinate 0, so it lies in the XOZ plane. We mark minus 4 on x in this plane, that is, in this direction, somewhere here, and 3 on z, up 3. We draw straight lines. Draw a straight line through this point, which is parallel to the z-axis. A straight line parallel to the x-axis through this point. Intersection is a point D and point E. It has no 0 coordinates, so it will hang in space. It has 1 x, 2 on y. Let's mark 2 on y. We've drawn parallel lines. We've got a point. Now 3 points up from this one, parallel to the OZ axis. That is somewhere here. This is point E. This video lesson is over.